One function or injective functions are yet another class of functions which can be defined as a function f from a to b is called one function or injective function if range of function f contains only distinct elements, which essentially means that distinct elements of the domain have distinct images in the range. Mathematically, whenever we are required to prove that a given function is one, this is what we do. We assume the two images are equal and we prove that if the images are equal, then the corresponding elements in the domain are also equal. So we illustrate with help of this figure on the right side. Let's take two elements. Let's call this as x1 and call this as x2, and the corresponding images in set B are f of x1 and this will be f of x2. Let's call this as set A, and the rule which transforms elements of set A into elements of set B is called f. And now we are going to prove this with help of an example. The example here is show that f from R to R defined by f of x equal to x square is not one function, If we are required to prove that this function is not one, let's take the images of two distinct elements of the domain as same. So for this, let x1 and x2 belong to R, the domain set, such that f of x1, and this is how we are going to do always. We will consider two elements in the range are equal. So we assume f of x1 is equal to f of x2. This means if this is so, then x1 square is equal to x2 square by definition. But this does not mean that x1 is equal to x2. If x1 square is equal to x2 square, it doesn't mean that x1 is equal to x2. Well, the contradictory example, if x1 was equal to 2 and x2 was equal to -2, imagine what would be x1 square and what would be x2 square. They will be equal because x1 square will be 4 and x2 square of -2 will be 4 again. So this does not mean that 2 is equal to -2. That's why this function is not 1. But if we want to find out a function which is 1, let's take another example. Let's take any linear function. If f from R to R is defined by f of x equal to 3x minus 4, then show that f is injective function. All right, so now the solution would be, we are going to assume that f of x1 and f of x2 is equal, just like we explained in the procedure. for x1 and x2 belonging to R, assume f of x1 is equal to f of x2. If that is true, then by definition, what would be f of x1 equal to? Like if we transform x1, what would be that transformation, or what would be image of x1? That would be 3x1 minus 4, and similarly the transformation of x2 would be 3x2 minus 4. If this is true, then adding 4 on both sides, if we add 4 on both sides, we are left with 3x1 equal to 3x2. If we add both sides, and now if we divide both sides by 3, then x1 is equal to x2. If we divide both sides by 3, this means that if f of x1 is equal to f of x2, then the corresponding images are same as well, which ultimately means that the distinct elements of the domain will have distinct images in the range. So this is how we do. But if the function is being represented by an arrow, the short way of proving that the given function is 1, 1 is watch that two arrows can never be pointing to the same element in the range. Or if function is represented by arrow diagram, then two arrows cannot point to same element of the range. This is a little trick just in case if the given definition of function is in the form of arrow diagram. And there is another representation of the function, and that's tabular form, where the ordered pairs are given. If that is the case, then two pairs will never have the same element in the. So if function is given in tabular form, for function to be injective, two pairs can never have same element for second position of the pair. Position of the pair means that abscissa of every pair is distinct for second position of the pair. And one more thing before we finish this lesson, that if a given function is 1 1 as well as on 2, then that function is called bijective function. So let's write down the definition of bijective function. Bijective function. A function is called bijective. A function f from R to R is called bijective. If f is 1 1 1 1 as well as f is on 2. F is on 2.